All right, welcome back. Our last section in Chapter 9 is 9.7, Perimeters and Similarity. Our first theorem box here is if two triangles are similar, then the measures of their corresponding perimeters are the same proportion as their corresponding sides. So if I put this in words, perimeter of triangle ABC to the perimeter of triangle DEF is the same ratio as AB over DE, BC over EF, and AC over DF. They all have the same ratio. Excuse me. All right, first example here. The perimeter of triangle RST, so the perimeter of this smaller triangle is 9, and I know that the triangles are similar. Find the values of each variable. So the first thing I need to do is find the perimeter of triangle MNP. So that's going to be 3 plus 4.5 plus 6. So that perimeter is 13.5. Now, since I know that they're similar, I know that I can set the ratios up to figure out the missing lengths. So I'm going to use my ratio of my perimeters. So 13.5 over 9 is going to be equal to 3 over x. I'm going to do that 3 times. 13.5 over 9 is equal to 4.5 over z. And 13.5 over 9 is equal to 6 over y. Alright, that's my y. So, getting really good at this, we're going to do our cross products here. So 13.5x equals 9 times 3, which is 27. Divide both sides by 13.5. So 29 divided by 13.5 is 2.15. I'll round that to the nearest hundredth. Over here, 13.5 times z is equal to 9 times 4.5. 9 times 4.5 is 40.5. Now move this up a little bit. 40.5, divide both sides by 13.5. And I've got z is equal to, divide that by 13.5, got z is equal to 3. And then the last one here, that 13.5y is equal to 54. 54 divided by 13.5 is 4, so y is equal 4. Alright, so we've got our 3 sides of our triangles that are missing. Alright, again, same process here. We're going to first find the perimeter of our smaller triangle. So that's 16 plus 12 plus 20 is 20, 32, 48 is my perimeter of this triangle right here. I'm given this perimeter of my larger triangle is 72 units, so I'm going to go ahead and set up my first proportion, 48 over 72. And I know that's going to be equal to 16 over, that doesn't look like 16. Let's fix that. 16 over A. I'll go ahead and solve that one first. So I've got 48A is equal to 72 times 16 here. 72 times 16 is 1152. Divide both sides by 48. And I get A is equal to 24. We're going to go ahead and repeat that with the other sides here. So I'm going to move my page up a little bit. I'm going to use that same 48 over 72. And now I'm going to use 12 over B. So I've got 48B is equal to 12 times 72. 12 times 72 is 864. Divide that by 48. And I've got B is equal to 18. All right, and then the last side, again, we're going to go back to that first, oops, not 42, 48 over 72 is equal to 20 over C. So 48C is equal to 72 times 20. 72 times 20 is 1440. Divide that, both sides, by 48. And we come up with our last value of that triangle. C is equal to 30. So again, we used that first ratio of 48 over 72 in each side, because we know if the triangles are similar, the proportions of their perimeters are the same as the proportions to their sides. All right, slide here. Oops, I want to draw on that. Make that a little bigger for you. All right, we've got scale factor now. So, scale factor is the ratio. So we've got the ratio found by comparing the measures of the corresponding sides of similar figures. Okay, so if I'm making something bigger, like blowing up a picture, enlarging a picture, or making a scale-size model of a drawing or a building, etc., we're going to use scale factors. So our scale factor is from the larger triangle to the smaller triangle. So we want to make sure we're going from the big triangle to the small triangle for all of our ratios. So UV over XY is equal to 10 over 6. And then I've got VW over YZ. Again, I'm going from large to small. Is 15 over 9. And then the last one, UW over XZ is equal to 20 over 12. When we reduce all of those fractions, that's going to give us our scale factor. 10 and 6, I can divide them both by 2. 10 divided by 2 is 5. 6 divided by 2 is 3. 15 and 9, I can divide those both by 3. 15 divided by 3 is 5. 9 divided by 3 is 3. And then the last one, 20 and 12, I see that I can divide those both by 4, and I get 5 over 3. So the scale factor from the larger triangle to the small triangle is 5/3. And again, that's just by using those ratios. All right, and the last example here, suppose that triangle SLC is similar to triangle GFR, and the scale factor of SLC to GLR, or GFR, is 2/3. So I'm going to write a proportion here. Oops, I don't want the marker highlighter. So I've got triangle SLC going to triangle GFR. And that's coming from this statement right here. And I know that's equal to my scale factor, which is 2/3. Okay, and so we're trying to find the perimeter. If I already know my perimeter right here of SLC is 14, and again the perimeter and the sides are all the same proportion, so I'm going to use that 2/3. So 2/3 is equal to, and I know SLC is my triangle that goes on top, 14 over x. Again, we're getting really good at our proportions here, so cross multiplying. I've got 2x equals 14 times 3, so 2x equals 42. Oops, there's my dead spot. Let's see if I can erase that, sorry. Move that up. Oops. So, oh, now it's not moving. Let's try. All right, well, we'll just go with it. Is equal to 42. I'll do that down here. So 2x is equal to 42. Divide both sides by 2. I've got x is equal to 21. So the perimeter of triangle GFR is 21 inches. Again, that was using those proportions and that scale factor ratio. All right, don't want to move everything. Down here at the bottom, you've got your next practice. Assignment number 10, last assignment. Practice worksheet number 9.7. Go ahead and see us if you have any questions.